What if we're traveling through the galaxy without realizing it, deep within the silent oceans of space, far beyond the warm cradle of sunlight that surrounds our world? A question rises like a distant signal from the void, faint, unsettling, impossible to ignore. It is a question that challenges everything we believe about our place in the cosmos, everything we assume about motion, stillness, direction, and destiny. For centuries, we have looked up at the stars believing that Earth is a fixed home, a stable platform drifting slowly and predictably through the galaxy. But what if that belief is not only incomplete, not only naive, but catastrophically wrong? What if Earth is not merely drifting, not simply orbiting, but traveling through the galaxy in ways we have never imagined, at speeds, trajectories, and dimensions that escape our senses entirely? And what if this journey is not passive? What if we are passengers aboard a vessel we do not yet understand? Consider the staggering truth hidden behind the gentle blue sky above us. Earth is never still. Not for a moment. Not for the blink of an eye. It spins at over 1,600 kilometers per hour. It orbits the Sun at 107,000 kilometers per hour. The Sun, dragging the entire solar system, races around the center of the Milky Way at over 828,000 kilometers per hour. And the Milky Way itself flies through intergalactic space at nearly 2 million kilometers per hour. Yet to us, everything feels calm, stable, motionless. Our senses evolved for survival on a planet, not for perceiving the grand motions of celestial mechanics. The universe is in constant motion, and we, paradoxically, cannot feel any of it. But this is only the beginning. The more we learn about the universe, the more this illusion of stillness dissolves. Modern astrophysics reveals that space itself is not a static backdrop. It is dynamic, turbulent, and woven with structures so vast that they defy ordinary comprehension. Our solar system drifts through regions of interstellar space with different densities, magnetic fields, and radiation levels. It passes through colossal structures such as the local bubble, an immense cavity of hot plasma carved by ancient supernova explosions. Our entire galactic neighborhood, including the Sun and its planets, moves through the enormous Laniakea supercluster, a gravitational continent of galaxies. Yet through all of this, humanity carries on, blind to the cosmic tides sweeping beneath our feet. We perceive none of it. We question none of it. We notice nothing. This strange blindness leads to a profound possibility. If we cannot feel our own motion through the galaxy, what else are we missing? What if the true shape of our cosmic journey is far more complex, far more extraordinary than the simple orbits described in textbooks? What if, as some scientists quietly speculate, the solar system is not only moving through space, but being carried along by structures we have barely begun to detect? What if we are already travelers aboard a vast, ancient, cosmic river, and we've never realized it? The idea sounds outlandish, impossible, but consider this. The universe contains structures that stretch across hundreds of millions of light years. Cosmic filaments, dense strands of dark matter and galaxies, form an immense cosmic web that encircles the observable universe. Some of these filaments act like highways for matter, guiding galaxies along predetermined routes shaped by gravitational flows. We know that the Milky Way is pulled by such a flow toward a mysterious region known as the Great Attractor, a gravitational anomaly so massive and so obscured by cosmic dust that we still cannot fully see it. The fact that we are being pulled towards something we barely understand should unsettle us. For decades, researchers have attempted to map these gravitational flows and reconstruct the true motion of our galaxy. What they found is astonishing. Our galaxy is not simply orbiting, but falling towards structures of incomprehensible scale, toward cosmic anomalies whose nature remains unknown. The solar system is a passenger within a galaxy in motion, and the galaxy itself is a passenger in a much larger journey. Our path is not a simple orbit, but a spiraling, accelerating trajectory shaped by forces we cannot perceive. And this raises a disturbing possibility. What if this motion is not natural? For the first time in history, astrophysics and cosmology hint at patterns in the galaxy's motion that defy simple explanation. Some researchers have noticed that the Sun follows a peculiar helical trajectory through space, more like the path of a guided projectile than the smooth orbit described in classical models. Others have observed that the solar system's tilt relative to the Milky Way's plane suggests an origin or influence that does not align with known gravitational dynamics. Even more unsettling, the galaxy itself shows signs of being aligned along axes that some cosmologists refer to, half-jokingly, as the axis of evil, patterns in the cosmic microwave background that should not exist if the universe evolved randomly. These anomalies raise a chilling question. What if our motion is not merely the result of gravitational drift? What if something guides us? This idea becomes even more intriguing when we consider a profound shift in our understanding of space itself. Quantum field theory and general relativity, two pillars of modern physics, suggest that space is not empty. It is filled with fields, particles, and fluctuations that interact with matter in ways we still do not fully understand. Motion through these fields may produce effects we have never measured. Some theorists speculate that dark matter, which forms the majority of the universe's mass, could influence the motion of galaxies in ways far more complex than simple gravity. Dark matter might have currents, eddies, or flows, like invisible winds pushing entire star systems through space. If this is true, then Earth is not merely orbiting or drifting. Earth is sailing through cosmic winds, along dark rivers, across gravitational tides, and we sense none of it. Imagine for a moment that we are traveling not simply through empty space, but through a structured environment, one shaped by forces and patterns that are ancient, powerful, and hidden. Imagine that our solar system is moving along a predetermined route carved by invisible cosmic architecture, a route followed by countless other systems, a route that may have existed long before the sun was born. This speculation may not be science fiction. Recent simulations of galaxy formation show that star systems do not form randomly within spirals. They follow inheritance patterns shaped by the cosmic web itself. Some clusters appear to move along predetermined paths, guided by flows of dark matter. The idea that the galaxy contains traffic lanes, cosmic freeways invisible to our senses, is becoming increasingly plausible. And so the question becomes darker, deeper, far more fascinating. Are we traveling through the galaxy without realizing it because the mechanisms guiding our motion are invisible, or because someone designed it to be that way? For centuries, humanity has assumed that we are alone, insignificant, a cosmic accident drifting through the void. But what if the opposite is true? What if our location, trajectory, and speed are not accidents, but consequences of a larger structure hidden beneath the surface of reality? What if we are embedded within a system designed to ensure that civilizations travel through the galaxy at precise rates, along particular routes, toward destinations we cannot yet see? Such a notion invites skepticism, even ridicule. Yet history shows that civilizations often misunderstand their environment until technology lifts the veil. Early humans believed the Earth was flat because the curvature was too large to detect. They believed the sun revolved around the Earth because motion on the cosmic scale was unfathomable to the naked eye. What if our belief in passive galactic motion is just another illusion, one born from our sensory limitations and technological infancy? If we are unknowingly traveling, then where are we going? And why, who, or what determined this journey? Beneath these questions lies a final, unsettling possibility. Modern physics suggests that motion through space can be indistinguishable from the effects of acceleration if the reference frame is large enough. In other words, you could be accelerating right now, entire civilizations could be, and you would feel nothing. If our entire galaxy is accelerating towards something, or being propelled by something, we would never know, not yet. We might already be traveling faster than we ever imagined, across a map larger than the universe we think we see. And the truth of our journey may be written in patterns we have overlooked for centuries, waiting for someone to understand them. If the thought that we may be gliding unknowingly through a cosmic current feels unsettling, the deeper implications are even more profound. Imagine for a moment that Earth is not simply drifting through the galaxy, but being carried not by random gravitational motions, not by the predictable curves of orbital mechanics, but by something far more enigmatic, something woven into the very architecture of the universe. The possibility that we are traveling through a structured, directional flow of space-time transforms our understanding of existence itself. It suggests that our journey is neither accidental nor meaningless, but part of a far larger pattern, one that humanity has never perceived because our senses evolved to detect predators in the grass, not the tides of galactic motion. We often imagine space as a vast emptiness, a dark and silent vacuum dotted with the distant glow of stars. But space is not empty. It is a landscape, a dynamic, textured environment filled with invisible currents, magnetic storms, fields of dark matter, rivers of plasma, and gravitational waves. These forces shape the motion of galaxies, stars, planets, and every particle that has ever existed. The problem is that human beings are tiny, fragile biological organisms designed to perceive slow movements and local interactions. We cannot sense the immense flows that govern the galaxy any more than a single cell in our bloodstream can sense the motion of the entire body. To us, Earth feels still and calm, but in truth, we are hurtling through a cosmic ocean whose currents have been flowing since before the sun ignited. The more scientists study the galaxy, the clearer it becomes that our solar system's path through space is not a simple orbit. It is a spiraling, twisting, accelerating trajectory shaped by forces we do not fully understand. The sun itself does not move in a smooth circular path around the center of the Milky Way. It oscillates above and below the galactic plane like a suspended weight bouncing along a cosmic string. This motion creates periods when the solar system plunges through dense regions of interstellar material, followed by eras of calm, then turbulence, then radiation-rich expanses where cosmic rays rain upon Earth in intensified waves. Some researchers have proposed that these oscillations correlate with mass extinctions, climate cycles, and evolutionary leaps in Earth's history. If that is true, then our journey through the galaxy is not passive. It is dangerous, transformative, and deeply consequential. But what if the oscillations themselves are not purely natural? What if they result from interactions with structures we have not yet discovered? Structures that may stretch across light years or remain invisible to current instruments. One possibility is that dark matter, the mysterious substance that outnumbers ordinary matter by a factor of 5, forms dense thread-like filaments. If our solar system crosses one of these filaments, its motion could shift dramatically, altering the behavior of comets, destabilizing planetary orbits, or triggering geological or biological changes on Earth. Yet we cannot see these filaments. We cannot detect them directly. We would never know we had crossed one, only that something inexplicable was happening. Then, there is the phenomenon of the local interstellar cloud, a turbulent region of gas through which the solar system is now traveling. This cloud appears to be held together by magnetic fields of unknown origin and strength. No one knows what happens when a solar system enters or exits such a structure. No one knows how these clouds interact with the heliosphere, the sun's protective bubble that shields Earth from cosmic radiation. Some astrophysicists speculate that Earth's climate could shift dramatically as we traverse different interstellar environments. Others suggest that cosmic rays could increase mutation rates, potentially influencing evolution. All of this could be happening right now, and once again, we would feel nothing. The sky would remain blue. Life would continue as if nothing were happening. But beneath the surface, beneath our awareness, the galaxy would be reshaping our destiny. The idea that we are unknowingly traveling through a galactic landscape becomes even more astonishing when we examine the sun's motion relative to other stars. The solar system's path is not solitary. It flows through space alongside countless other stars moving in coordinated patterns. Some of these stars appear to share origins with the sun, traveling in parallel like distant companions in a vast celestial convoy. Others are unrelated, but follow similar paths because they are caught in the same gravitational streams. These streams, known as stellar associations, clusters, and moving groups, are the fingerprints of ancient forces that sculpted the galaxy. They suggest that stars are not randomly distributed, but organized by invisible structures that may be relics of the galaxy's formation or manifestations of ongoing cosmic dynamics. If our solar system is embedded within such a stream, then our path through the galaxy might be predetermined on timescales far beyond human comprehension. We may be following a route laid down billions of years ago, long before the Earth formed. We may be moving along a path shared by countless other civilizations, past, present, or future, each unaware that they are part of a flow larger than themselves. If advanced civilizations exist elsewhere in the galaxy, they might understand these flows intimately, using them as transportation routes across interstellar distances. To them, the cosmic currents would be as obvious as ocean tides are to us. To us, they are invisible. This leads to a question that grows heavier with every discovery. What if advanced civilizations designed these routes? What if ancient technological forces, so old, so vast, that they have become indistinguishable from nature, once shaped the motion of stars and planets? Imagine a species capable of modifying dark matter itself, sculpting gravitational flows, or engineering the structure of space. Such a civilization might leave behind patterns so enormous that later generations would mistake them for natural cosmic architecture. The idea sounds impossible until we remember that humanity already modifies Earth's systems on a planetary scale. We alter climates, redirect rivers, flatten mountains, and build structures visible from orbit. Our impact across thousands of years is measurable. Imagine a civilization 1 billion years old. Imagine its impact on a galaxy. Yet even if no ancient intelligence shaped our path, the galaxy itself may possess natural mechanisms that behave like engineered systems. Consider the possibility that the Milky Way's spiral arms are not merely patterns of star formation, but dynamic structures that guide matter along predetermined routes. Recent research reveals that spiral arms may rotate at different speeds from the galaxy itself, creating regions where stars are trapped, accelerated, or redirected. If the solar system is caught in such a pattern, then our journey is akin to riding along a giant galactic conveyor belt. We are being pulled, guided, and shifted by forces older than time. And still, we feel nothing. This inability to perceive our own motion is not a flaw. It is a limitation of biology. Motion is relative. A passenger aboard a smoothly gliding spacecraft feels no sensation of speed. Only when the ship accelerates, turns, or collides with something does motion become perceptible. If Earth is moving through the galaxy in a stable, constant trajectory, we would never feel it. We would only notice if something changed, if the cosmic winds shifted, if the gravitational currents intensified, if we entered a region of space unlike anything we have encountered before. Such a transition could be catastrophic, transformative, or unnoticed entirely, depending on its nature. But perhaps the most profound implication is not that we are moving, but that we are moving somewhere. The galaxy is not static. It evolves, rotates, expands, and transforms. Star systems drift apart or spiral inward. Regions of star formation ignite like sparks across the disk. Supernovae carve cavities in interstellar space. Black holes sculpt gravitational landscapes. In such a dynamic environment, motion has consequences. Trajectories have destinations, whether by design or by chance. What, then, is the destination of the solar system's journey? Are we falling into the galactic center, where a supermassive black hole lurks? Are we drifting toward a region teeming with radiation and chaos? Are we following a path that will eventually cross the spiral arm, a region full of star-forming clouds that could destabilize planetary systems? Or are we moving toward a calmer region, a galactic oasis, where life has a greater chance of survival? We do not know. We have never known. Humanity lives as if Earth were anchored in place, but every species that has ever walked this planet, dinosaurs, trilobites, primates, microscopic organisms, lived and died aboard a world that was hurtling through the galaxy. Extinction events, evolutionary bursts, climate shifts, and geological upheavals may all be tied to our cosmic trajectory. The fossil record preserves life's history, but it also preserves the imprint of the galaxy itself, the scars left by invisible encounters, cosmic storms, and gravitational tides. What we call evolution may be the story of life adapting to a journey we never realized we were taking. To question our motion is to question our identity, our destiny, and our understanding of reality. Modern science acknowledges that we do not perceive most of the forces acting upon us. Our senses evolved for the Earth, not for the cosmos. But the cost of this blindness is that we may be passengers on a voyage we cannot comprehend, a voyage whose meaning, purpose, or danger remains hidden. If we are traveling through the galaxy without realizing it, then humanity stands at the threshold of a revelation that could redefine our place in the universe, our sense of purpose, and our understanding of the forces shaping our existence. We may discover that we are not static observers of the cosmos, but active participants in a journey as old as the stars themselves. And the true nature of that journey may be stranger than we ever imagined. If the universe is a vast and turbulent ocean, then our solar system is a ship whose sails we cannot see and whose rudder we do not understand. The more deeply we study the cosmos, the more we realize that motion through space is not governed by a single force, but by a symphony of interacting influences, some known, many unknown, and others so extraordinary that they blur the line between natural processes and cosmic engineering. To understand the possibility that we are traveling through the galaxy without realizing it, we must first confront the invisible mechanisms that shape our journey, the hidden structures that guide our path, and the profound truth that the cosmos may be far more organized, dynamic, and intentional than we ever imagined. One of the most overlooked aspects of our cosmic voyage is the fundamental nature of spacetime itself. Far from being an empty, passive backdrop, spacetime is a fabric that bends, twists, vibrates, and folds in response to matter and energy. Einstein's theory of general relativity revealed that gravity is not a force, but a curvature of this fabric, and every mass, from planets to stars to galaxies, creates ripples in the cosmic ocean. But relativity describes only part of the picture. Quantum field theory tells us that even in perfect vacuum, space is teeming with fields and particles that flicker into existence and vanish in trillionths of a second. These fluctuations, known as zero-point energy, form a restless sea beneath the visible universe. Our solar system swims through this sea, and we have no idea how these fluctuations affect large-scale motion. We know that they influence particles, atoms, and molecules, but the effects on star systems drifting through the galaxy remain entirely unexplored. Could the vacuum itself exert currents, quantum winds, that push entire star systems across the galactic disk? Could the quantum foam beneath space-time produce directional flows on unimaginable scales? If such currents exist, they would be invisible, undetectable, and utterly beyond the limits of human perception. And yet, they could be steering us like a leaf drifting along a river none of us can see. Beyond quantum fields, the next hidden mechanism is something that still haunts modern physics: dark matter. This mysterious substance forms the skeletal framework of the universe, holding galaxies together and shaping their rotation. Dark matter does not emit light, reflect it, or absorb it, making it completely invisible. We know it exists only because it alters the behavior of gravity on cosmic scales. But what we do not know is far more important. We do not know its composition, its interactions, or its structure. Increasingly, astrophysicists suspect that dark matter may not be evenly distributed. Instead, it may form clumps, streams, rivers, and filaments that cut through the galaxy like unseen gravitational highways. If our solar system is passing through one of these structures, it could be accelerating or altering its trajectory in ways we cannot detect with current technology. Dark matter streams might act like cosmic conveyor belts, pulling star systems along predetermined routes. If a civilization understood dark matter the way we understand ocean currents, they could theoretically navigate the galaxy by riding these invisible flows. But humanity is still blind to dark matter. We drift through it without feeling it, without seeing it, without understanding it, just as ancient sailors crossed oceans without understanding tides or wind patterns. Another hidden mechanism shaping our motion is the sun's interaction with the interstellar medium. As the solar system travels through the galaxy, it moves through clouds of gas, regions of plasma, pockets of radiation, and magnetic fields of staggering complexity. The sun's magnetic field interacts with these environments, compressing the heliosphere, the protective bubble surrounding the solar system, changing its shape and influencing the flow of cosmic particles. These interactions may subtly push or pull the solar system, altering its long-term trajectory. Yet these forces are too vast and too gradual for human senses to detect. Even more intriguing is the possibility that the galaxy itself contains large-scale structures that influence motion in ways we do not yet understand. Recent studies suggest that the Milky Way's spiral arms are not static. They may be shock waves, density waves, or gravitational patterns that move through the galaxy independently of the stars themselves. If the solar system encounters one of these waves, its motion could shift dramatically. Over millions of years, such interactions could create complex trajectories that appear chaotic, but follow deeper patterns shaped by galactic architecture. In other words, the galaxy may contain its own form of weather, storms, currents, and tides that guide the motion of star systems. But these natural mechanisms are only part of the story. Some theories push us toward an even more provocative possibility. What if our motion is influenced by structures or technologies left behind by ancient civilizations? Humanity often assumes that advanced civilizations must build structures on planetary surfaces, cities, machines, or artifacts we can touch. But a civilization millions or billions of years older than us might build on a scale that defies comprehension. They might sculpt gravitational fields, engineer dark matter flows, or manipulate space-time itself. Their structures would not be cities or monuments, but vast invisible frameworks woven into the galaxy's architecture. To us, such structures would appear indistinguishable from natural forces. To them, they would be tools, modes of transportation, communication, or energy distribution. Imagine a civilization capable of altering the gravitational structure of a region of space, creating a corridor that channels star systems along a specific trajectory. Such a structure could exist on a scale larger than our entire galaxy. It could guide matter along the cosmic web, shaping the formation, motion, and evolution of galaxies. If we encountered such a structure, we would interpret it as a natural gravitational anomaly. We would call it the Great Attractor, the Shapley supercluster, or the dipole repeller, terms invented to describe phenomena we do not yet comprehend. But to an ancient civilization, these anomalies might be engineered systems, galactic-scale machinery, still operating long after their creators disappeared. The possibility that our path through the galaxy is influenced by ancient engineering forces us to question everything we know about cosmic history. Humanity measures time in tens of thousands of years. Civilizations rise and fall in centuries. Our entire recorded history spans barely 5,000 years. But the galaxy is over 13 billion years old. If intelligent life emerged anywhere in that time, it could have risen to heights beyond our imagination. It could have modified entire star systems, sculpted galactic arms, or created transportation networks across interstellar distances. And we, newcomers to the cosmos, would mistake these ancient mechanisms for natural phenomena. Yet even without invoking ancient civilizations, physics alone suggests that our journey through the galaxy is shaped by forces we barely understand. Consider gravitational waves, ripples produced by colliding black holes and massive cosmic events. These waves stretch and compress space-time as they pass through it. Though we only detect the largest waves, countless smaller ones pass through Earth every day, altering space-time on microscopic scales. Over millions of years, even microscopic distortions could influence the motion of star systems. If such waves form patterns or originate from repeated events, they could create long-term currents in space-time, currents that carry star systems through the galaxy. Another hidden mechanism may lie in the structure of the universe itself. Some theories propose that space-time is not smooth, but composed of discrete units, like the pixels of a cosmic screen. If this is true, then motion through space might be influenced by the geometry of this grid. Certain directions might offer less resistance, guiding stars along preferred paths. If the universe has such a structure, then every galaxy, star, and planet is following routes encoded into the geometry of reality itself. But perhaps the most extraordinary mechanism of all is one we have barely begun to explore: the possibility that the solar system is part of a larger cosmic cycle, one that repeats across billions of years. Recent astrophysical research suggests that our galaxy and its neighboring galaxies may be part of a rotating system, orbiting around an even larger gravitational center. If true, then our motion is not random, but part of a vast, orderly dance that has been occurring since the dawn of time. Each cycle of this dance could influence star formation, evolution, cosmic radiation levels, and the emergence of intelligent life. We may be moving through a pattern that determines when civilizations rise, when they fall, and whether they ever communicate with one another. If all of this is true, if our solar system is carried by invisible forces through a structured cosmic environment, then humanity is not a static species, but a traveling one. We are voyagers in a journey that began before Earth existed and will continue long after humanity has faded. Our ancestors crossed oceans without understanding the currents beneath their boats. We cross the galaxy without understanding the forces beneath our world. To realize that we are traveling through the galaxy without knowing it is to confront a profound truth about the universe, that reality is far larger, deeper, and more dynamic than our senses allow us to perceive. Our bodies evolved to survive on one planet, but our destiny may lie across the stars. Whether our journey is natural or engineered, random or guided, peaceful or dangerous, we are passengers in a voyage we have only just begun to understand. And the mechanisms that move us may be the key to unlocking the next stage of human evolution. For countless generations, humanity has lived with the comforting illusion that Earth is a stable home, a world that sits quietly in a peaceful corner of the universe while the stars drift far above our heads. Even as science revealed that Earth rotates, orbits, and travels through space at impossible speeds, the sensation of stillness persisted, reinforcing the ancient belief that our planet is a fixed stage and that the cosmos moves while we remain anchored. But this illusion, however familiar, is disastrously incomplete. The deeper we gaze into the fabric of the universe, the clearer it becomes that stillness is a mirage, motion is constant, and the paths we travel through the galaxy are far more complex than any orbit drawn in a textbook. The truth is far stranger. Earth may be navigating a cosmic structure so vast and so subtle that we have spent millennia moving across it without ever perceiving its existence. To understand why this illusion persists, we must first revisit what motion really means. Motion is not absolute, it is relational. We perceive motion through acceleration, vibration, resistance, and contrast. A person on a smooth, silent train feels still until the train turns, brakes, or collides with something. In the same way, Earth moves through space with a steadiness so perfect that we feel none of it. There is no cosmic wind to brush against our skin, no stellar friction to tug at our bodies. Space offers no air, no surface, no reference point. Even the blazing speed of light, 300,000 kilometers per second, does nothing to reveal our place in the galaxy. The absence of sensation creates the illusion that we are stationary, when in reality, we are racing through a universe filled with invisible forces. This brings us to a startling possibility. If we cannot perceive motion on planetary scales, then what if our understanding of the solar system's journey is dramatically incomplete? What if the smoothness we interpret as stillness is the product of a larger structure, one designed to carry us through the galaxy with perfect efficiency? What if our entire cosmic environment, from the orbit of the planets to the position of our star, is arranged in ways we do not yet comprehend? The more we learn about the galaxy, the more the evidence points toward an architecture of motion that is invisible, ancient, and astonishingly complex. At the heart of this architecture lies a force we scarcely understand: gravity. Gravity shapes the cosmos, yet it remains one of the greatest mysteries in physics. General relativity describes gravity as the curvature of spacetime, but it does not explain why mass curves spacetime or what spacetime itself is made of. And relativity breaks down at quantum scales, suggesting that gravity might be the emergent behavior of deeper, hidden processes. Some theories propose that gravity is not a fundamental force at all, but a side effect of information encoded on the fabric of reality. If gravity emerges from information, then motion through space may follow patterns written into the universe itself, patterns that guide star systems like arrows following lines drawn across the cosmic tapestry. One such pattern is the rotation curve of the Milky Way. For decades, astronomers have struggled to explain why stars in the outer regions of the galaxy rotate at the same speed as those near the center. According to classical physics, the outer stars should move slower, but they do not. This anomaly suggests that unseen mass, dark matter, shapes the galaxy's motion. But recent studies propose something even stranger, that the rotation curve may reflect a deeper geometric property of spacetime, one that forces motion to follow specific trajectories. If this is true, then our solar system's path is not arbitrary. It is guided by a framework embedded in the galaxy's very structure. This framework becomes clearer when we examine the cosmic web, the vast, three-dimensional structure that connects galaxies into filaments, sheets, and clusters. Far from being randomly scattered, galaxies gather along invisible scaffolding made of dark matter. These structures form highways that guide the motion of galaxies and star systems. Scientists now believe that the Milky Way itself flows along one of these filaments, pulled by gravitational currents toward massive attractors. Our solar system rides within this stream, moving along a path older than the stars. This path is not a simple orbit, but a journey shaped by the web's gravitational architecture. But gravity is not the only force guiding us. Magnetic fields stretch across the galaxy like invisible threads, twisting and bending in response to stellar winds and cosmic plasma. The Milky Way's magnetic field is colossal, with lines of force extending thousands of light years. These fields shape the flow of charged particles, influence star formation, and interact with interstellar clouds. But they may also affect the motion of entire star systems. Some astrophysicists propose that the solar system's trajectory is subtly influenced by galactic magnetic fields, especially as it passes through magnetized regions of interstellar space. These interactions could guide our motion, like the subtle push of a current on a drifting boat. The interstellar medium, the mixture of gas, dust, radiation, and plasma filling space, also plays a role. As the solar system moves through this medium, it encounters regions of varying density, temperature, and composition. These regions can compress or expand the heliosphere, alter cosmic radiation levels, and potentially influence planetary climates. But they may also exert tiny cumulative forces that shift the solar system's motion over millions of years. If these forces create long-term patterns, then Earth's journey through the galaxy is shaped by an interstellar landscape far more dynamic and structured than we ever imagined. We must also consider the influence of massive cosmic events. Supernova explosions send shockwaves through space, carving cavities and launching waves of plasma that travel for thousands of light years. Gamma-ray bursts create radiation storms capable of altering the chemistry of entire star systems. Black holes distort spacetime with gravitational waves that ripple across the galaxy. Each of these events interacts with the solar system's path, altering its motion in deep time. Over billions of years, the cumulative effects of such events could guide the solar system along a path that appears smooth and natural, but is, in reality, shaped by countless invisible interactions. Yet even these mechanisms do not fully explain the illusion of stillness or the possibility that our motion is guided. For that, we must confront a concept that lies at the edge of modern physics: the anisotropy of the universe. Observations of the cosmic microwave background, the afterglow of the Big Bang, reveal anomalies that defy expectations. Temperature variations across the sky form alignments that should not exist if the universe developed randomly. Some cosmologists call this alignment the axis of evil, a term born from its unsettling implications. The alignment suggests that the universe may have a preferred direction, a cosmic orientation embedded in space-time. If the universe has such a direction, then motion through the cosmos is not perfectly symmetrical. It is guided along paths defined by the underlying geometry of reality. This raises an extraordinary possibility. What if the solar system's motion follows one of these preferred directions? What if the universe itself has built-in pathways, cosmic routes that guide matter across unimaginable distances? If so, then the solar system is not simply drifting, but following a trajectory encoded into the fabric of the cosmos. This trajectory could be part of a larger pattern, one shared by countless galaxies and star systems. We may be moving along a route that is natural, ancient, and universal, a route that every star system eventually follows. But there is a darker possibility. What if this trajectory is not simply natural, but engineered? What if the universe's large-scale structure reflects the influence of ancient intelligence, civilizations that modified space-time itself to create pathways, signals, or guidance systems? A civilization a billion years old would not build roads or satellites. It would manipulate gravitational fields, dark matter, and the geometry of space-time. Its structures would be invisible, its architecture cosmic, its legacy woven into the universe's very shape. If such civilizations existed, their influence would be indistinguishable from natural forces. We would interpret their structures as anomalies, gravitational anomalies, magnetic alignments, or cosmic filaments. But these structures could be relics of technologies far beyond our understanding. The cosmic web might be more than a natural formation. It could be the remnant of ancient engineering, The alignment of galaxies might reflect the work of civilizations that shaped the universe before our sun was born. And the pathways we follow through the galaxy could be intentional, designed to guide civilizations toward regions of stability or opportunity. This perspective forces us to reconsider our understanding of the cosmos. We assume that nature operates without intention, that the universe is indifferent to life. But if advanced civilizations modified the universe, then life may be moving along routes designed to maximize survival or communication. The solar system's position within the galaxy, its path through interstellar space, and even the timing of evolutionary events on Earth might be influenced by forces we have not yet recognized. Yet even without invoking ancient intelligence, the evidence suggests that our motion is guided by structures we cannot perceive. The galaxy is a dynamic system, filled with patterns, flows, and cycles that shape the journey of every star. The illusion of stillness arises because we are passengers on a vessel moving so smoothly, so perfectly, that we cannot feel the motion. But the vessel is real, the path is real, the journey is real, and the architecture guiding that journey may be the key to understanding our place in the universe. If Earth truly is traveling along a structured route through the galaxy, one shaped by gravitational currents, magnetic fields, dark matter flows, cosmic alignments, and unseen forces, then humanity is not simply observing the cosmos. We are part of it. We are embedded within it. We are moving through a design older than the sun, guided by mechanisms beyond our senses. The realization that we are traveling through the galaxy without knowing it is not simply scientific. It is existential. It challenges our perception of stability, our assumptions about nature, and our understanding of destiny. It suggests that the universe is not a passive backdrop, but an active environment, one that shapes us, guides us, and moves us toward unknown future events. Perhaps the greatest illusion of all is not that Earth is still, but that we are alone. If everything we have explored until now suggests that motion through the galaxy is far more complex, guided, and structured than we ever imagined, then the next question emerges with the weight of a cosmic revelation. What if our journey is not simply shaped by natural phenomena, but by technologies, infrastructures, or intelligence so ancient and so advanced that they have merged seamlessly with the fabric of the universe itself? If humanity is traveling through the galaxy without realizing it, it may not be because the mechanisms are invisible. It may be because they were designed to be invisible, operating at a scale, speed, and subtlety that escapes all human senses and instrumentation. The possibility that ancient cosmic engineering influences our path is not a leap into fantasy, but a logical extension of what we already observe. Galactic structures that defy randomness, gravitational anomalies that suggest hidden architecture, and alignments so vast and precise that no natural explanation fully accounts for their consistency. To understand this possibility, we must step back and consider the nature of intelligence on cosmic timescales. Human civilization is a recent flicker, barely a few thousand years old, with technological capabilities measured in decades. By contrast, the universe is 13.8 billion years old. If intelligent life arose elsewhere long before us, and statistically, it is almost impossible that it did not, then some civilizations could be billions of years older. In a billion years, species could evolve, expand, develop technologies that manipulate matter at quantum scales, and harness energies that we cannot even define. In that time, they could reshape stars, sculpt galaxies, and design structures that appear to us as natural features of the cosmos. We tend to imagine advanced civilization in limited human terms: cities, spacecraft, radio transmissions. But such concepts belong to the infancy of intelligence. A civilization capable of surviving cosmic threats, mastering physics, and thriving for eons would likely transcend material architecture entirely. Instead of building machines, they might modify the laws of physics within local regions. Instead of constructing structures, they might sculpt spacetime. Instead of traveling between stars, they might create gravitational currents that carry entire star systems along predetermined routes. Their technologies would be indistinguishable from the mechanisms we currently call natural phenomena, and this is where the possibility becomes extraordinary. What if the cosmic web, the dark matter filaments, the gravitational flows, and the alignments of galaxies are not simply natural structures, but the remnants of ancient engineering? What if advanced civilizations, long vanished or transformed beyond recognition, shape the galaxy to guide matter, energy, and life along specific trajectories? The idea is not new. Pioneering physicists like Freeman Dyson have suggested that sufficiently advanced civilizations would manipulate stars themselves. Others have proposed that black holes could be used as energy sources or even computational engines. If such civilizations exist, their works would be beyond our comprehension, appearing to us as cosmic architecture embedded within nature. One possible example lies in the phenomenon of the Great Attractor, a region of immense mass that pulls entire galaxies, including the Milky Way, toward it. For decades, astrophysicists have attempted to explain this gravitational anomaly, but its nature remains elusive. Some theories propose that it is a cluster of galaxies hidden behind the Milky Way. Others suggest that it is a larger structure, a gravitational well shaped by dark matter. But if ancient civilizations possessed the ability to manipulate dark matter or create massive gravitational fields, they could have engineered structures like the Great Attractor to influence the motion of galaxies. To such beings, shaping the trajectory of star systems would be akin to designing rivers or highways on a planetary surface. This possibility becomes even more compelling when we examine the mysterious dipole repeller, a region of space that appears to push galaxies away with unusual force. Combined with the Great Attractor, these regions create a cosmic flow, guiding galaxies along pathways that resemble currents in an ocean. If these forces were engineered, they could form part of an intergalactic transportation network designed to distribute matter, energy, or life across the cosmos. Humanity, unaware of the forces shaping our galaxy's motion, would be drifting along these currents like a leaf on a river. But why would ancient civilizations shape such structures? What purpose would it serve? The answer may lie in the concept of cosmic stewardship, the idea that advanced civilizations take responsibility for guiding the evolution, distribution, and survival of life throughout the universe. If a species develops the ability to manipulate gravitational structures, influence dark matter flows, or engineer spacetime, they might use these capabilities to ensure stability across vast regions of the cosmos. They could create safe zones, routes for travel, or regions conducive to star formation. They could also construct barriers, regions designed to isolate dangerous phenomena or prevent catastrophic interactions between galaxies. Another possibility is that these structures serve as communication networks. Recent studies suggest that gravitational waves can carry information across the universe with minimal distortion. If ancient civilizations developed the means to encode information into gravitational waves or dark matter structures, they could create a message system that persists for billions of years. These messages could be embedded in the cosmic web, the alignment of galaxies, or the distribution of mass across the universe. To interpret such messages, a civilization would need to reach advanced levels of physics, levels humanity is only now beginning to approach. But cosmic engineering need not be intentional to influence our journey. Some structures could be the byproducts of technologies far beyond our understanding. Just as our antennas emit stray signals and our digital networks leak electromagnetic noise, ancient systems might leave behind artifacts, gravitational residues, quantum structures, or dark matter patterns that persist long after their creators have vanished. These remnants could guide the motion of galaxies inadvertently, creating corridors of motion that appear purposeful but are simply side effects of colossal technologies. If any of this is true, then Earth is not merely drifting through the galaxy, it is being carried subtly, smoothly, silently through a cosmic structure shaped by forces unknown. Our solar system may be traveling along a route established billions of years ago. We may be passing through regions of space selected for their safety, stability, or biological potential. Or we may be approaching a region where ancient structures converge, where gravitational currents accelerate, magnetic fields intensify, and the galaxy's architecture becomes more pronounced. This brings us to a profound question. Could our motion through the galaxy explain unexplained patterns in Earth's biological and geological history? Some paleontologists have noted periodic extinction events occurring roughly every 30 million years. Others have observed cycles in climate, biodiversity, and tectonic activity that seem to correlate with cosmic timescales. While many explanations have been proposed, comet showers, volcanic cycles, plate tectonics, another possibility is that Earth's journey through the galaxy exposes it to regions of space with different radiation levels, dark matter densities, or cosmic influences. If these regions were shaped by natural structures or ancient engineering, then life on Earth has been evolving under the influence of forces beyond our understanding. Even more extraordinary is the idea that our path through the galaxy could be guiding humanity toward higher levels of awareness, intelligence, or technological development. Some theories suggest that cosmic radiation can influence mutation rates, cognitive evolution, or even the emergence of consciousness. If this is true, then humanity's development may be intertwined with the galaxy's architecture. Our evolution may have been shaped not only by Earth's environment, but by the cosmic environment through which we travel. We may be products of deep space forces operating on timescales longer than life itself, but perhaps the most chilling possibility is that our journey has a destination. Not in the sense of a conscious design, though that cannot be ruled out, but in the sense that the galaxy's architecture funnels matter toward specific regions. If the cosmic web acts like a network of rivers, then star systems may naturally flow toward convergence points, regions where matter accumulates, where galaxies merge, or where cosmic structures intensify. These regions may be sites of great danger or extraordinary opportunity. They may contain phenomena beyond comprehension, ancient civilizations, hyper-advanced technology, supermassive black holes, or regions where the laws of physics themselves begin to shift. Whether the destination is natural or engineered, humanity may already be on its way. We may be approaching regions where cosmic forces intensify, where interstellar conditions change dramatically, or where ancient structures exert stronger influence. And we remain oblivious to all of it. We live our lives on a tranquil world, unaware that we are passengers on a star system moving through the galaxy at unimaginable speeds, guided by invisible forces, influenced by structures older than Earth, and carried along currents we have never sensed. If ancient cosmic engineering exists, it may explain why the universe appears strangely fine-tuned for life. It may explain why certain regions of the cosmos produce stars and planets capable of supporting biology. It may explain why the Milky Way has spiral arms, structures that act like galactic highways. It may even explain the emergence of intelligent life itself, if ancient civilizations seeded regions of space with the raw ingredients for consciousness. Humanity stands on the threshold of understanding none of this and all of this at once. We are beginning to detect gravitational waves, map dark matter, analyze cosmic filaments, and observe the large-scale structure of the universe. We are developing the tools to see the invisible architecture that guides our motion. And when we finally see it, when the cosmic map is revealed in full, we may realize that we have been traveling through a vast, ancient, and intelligent landscape for millions of years without ever knowing it. Earth is not still. Earth is not isolated. Earth is not merely orbiting the sun. Earth is traveling through a galaxy rich with structure, shaped by forces beyond our comprehension, influenced by ancient engineering or deep cosmic physics, and guided along a path whose destination remains unknown. And the greatest mystery of all is not that we have failed to see this journey, but that the universe has hidden it so perfectly that we believed we were standing still. If we are traveling through the galaxy without realizing it, then the implications extend far beyond celestial mechanics, gravitational currents, or ancient engineering. Such a journey would reach into the core of who we are, our evolution, our perception, our consciousness, and our very sense of reality. It would mean that human development has never been isolated, never been purely terrestrial, and never been shaped solely by earthly conditions. Instead, humanity would be a species sculpted by the invisible tides of the cosmos, molded by energies, particles, and forces encountered along an endless voyage through space. Every step of our biological and cognitive evolution might be the echo of distant regions of the galaxy through which Earth has drifted over hundreds of millions of years. To understand this possibility, we must begin with a simple but profound truth. Earth does not remain in a fixed cosmic environment. Our solar system travels through regions of space with different densities of radiation, cosmic dust, dark matter, magnetic fields, and energetic particles. Each region has its own signature, its own properties, and its own potential influence on biological systems. If consciousness and life are sensitive to electromagnetic fields, solar activity, cosmic rays, and high-energy particles, as numerous studies increasingly suggest, then the journey of Earth through the galaxy could be shaping our minds and bodies in ways we have only begun to imagine. Consider cosmic rays, subatomic particles accelerated to near light speed by supernovae, black holes, and other energetic cosmic events. These particles permeate space and penetrate Earth's atmosphere, sometimes altering DNA, affecting cellular processes, and influencing mutation rates. During periods when our solar system passes through dense cosmic clouds or encounters regions of intense radiation, the flux of cosmic rays increases dramatically. Some paleontologists have proposed that such periods correspond to bursts of evolutionary change, times when species experience accelerated mutation, rapid diversification, or sudden cognitive leaps. If so, then human intelligence may not be a random accident, but a response to cosmic forces encountered during our galactic voyage. But cosmic rays represent only one influence. Galactic magnetic fields vary across different regions, and Earth's magnetic field interacts with them. Some neuroscientists have discovered that the human brain, and even the brains of simple organisms, respond to magnetic fluctuations. Migratory animals navigate using magnetic sensitivity. Human brainwaves show subtle changes during geomagnetic disturbances. If our journey takes us through regions with changing magnetic intensities, then collective shifts in human behavior, creativity, mood, or even societal patterns could be tied to cosmic environmental cycles. Then there is the mysterious influence of dark matter, a substance that permeates the galaxy but interacts with ordinary matter through gravity alone. While conventional physics assumes dark matter is passive, some researchers propose that certain types of dark matter may interact weakly with biological systems. If true, then Earth's passage through dark matter, streams or filaments, could influence evolution, climate cycles, or even consciousness. Some theories speculate that dark matter could accumulate in Earth's core or biological tissues, subtly altering processes we cannot yet measure. These concepts may seem abstract, but we can measure their effects indirectly by examining changes in Earth's history. Certain mass extinctions, evolutionary bursts, and climate shifts appear to follow a periodic pattern, cycles of approximately 30 million years. Some astronomers propose that this cycle corresponds to the oscillation of our solar system above and below the plane of the Milky Way, or its passage through dense regions of the galactic disk. If that is correct, then cosmic influences do not merely shape evolution, they regulate it, guiding life through alternating periods of stability and upheaval, as if the galaxy itself breathes and life evolves in rhythm with this cosmic inhalation and exhalation. But what happens if consciousness itself is sensitive to these cosmic forces? Human thought has always been difficult to explain purely in biological terms. The emergence of self-awareness, creativity, abstract reasoning, and symbolic thought remains a mystery. Some neuroscientists argue that consciousness may be influenced by quantum processes inside neurons, phenomena that could be sensitive to cosmic radiation, magnetic fields, or unknown particles. If consciousness is not an isolated phenomenon, but a resonance between biology and environment, then Earth's movement through the galaxy could modulate the very structure of human thought. Imagine that different regions of the galaxy act like tuning forks, each emitting unique frequencies of radiation, gravitational waves, or quantum noise. As Earth passes through these regions, human consciousness could be entrained, subtly shifted into different modes. Periods of intense artistic flourishing, scientific revolutions, spiritual awakenings, or even widespread turmoil could correspond to transitions between galactic environments. Civilizations may rise and fall, not only because of internal dynamics, but because of the cosmic weather of the regions they traverse. This raises an extraordinary possibility. Human history may contain patterns correlated with our galactic motion. Some historians argue that eras of intellectual enlightenment, bursts of innovation, and cultural transformation occur in cycles. While most explanations are sociological, another explanation is that shifts in cosmic radiation or magnetic fields alter the collective human psyche. The Renaissance, the Axial Age, the Industrial Revolution, and the digital age might not be isolated events, but responses to a deeper cosmic rhythm. Even religions may contain echoes of cosmic transitions. Many ancient traditions speak of ages, golden ages, dark ages, cycles of awakening and decline. These might not be metaphorical. They might be memories, passed through myth, of how human consciousness expands or contracts depending on the cosmic environment. If ancient civilizations were more sensitive to cosmic energies, or had knowledge of our galactic journey, then their mythologies could encode cosmic truths about humanity's place in the universe. Another mystery emerges when considering the possibility that regions of the galaxy contain structures or phenomena designed to influence consciousness. If ancient civilizations achieved technologies capable of manipulating gravitational fields, altering radiation patterns, or generating artificial quantum environments, then they might have shaped corridors of space that stimulate cognitive development. Humanity could be passing through one such corridor without realizing it, experiencing subtle yet profound mental shifts. Our accelerating technological growth, increasingly abstract thinking, and expanding awareness of the cosmos could be side effects of entering a region shaped by ancient engineering. Alternatively, some regions might dampen consciousness. If Earth has passed through zones of silence, where cosmic energies suppress creativity or insight, then certain eras of stagnation or regression in human history might reflect the influence of these dead zones. This suggests that consciousness is not merely a biological property, but a phenomenon that blooms or withers depending on cosmic conditions. If our journey is indeed altering human cognition, then we may now be approaching a transition point, a region where cosmic influences intensify. Humanity's technological acceleration, the global awakening to existential questions, and the surge of interest in cosmic origins may be signs that we are entering a region of the galaxy that amplifies awareness. We may be awakening not because of cultural shifts alone, but because the environment around our solar system is changing in ways we have not yet detected. As cosmic rays increase, as magnetic fields fluctuate, as unknown particles flow through the solar system, the human mind may be responding instinctively, preparing for challenges or insights we have yet to comprehend. But there is a deeper, more unsettling implication. If consciousness is influenced by cosmic forces, then our identity, the sense of self, may not be static. It may be fluid, shaped by cosmic tides. Our thoughts, emotions, and beliefs might be modulated by the invisible sea we travel through. This challenges fundamental assumptions about free will, individuality, and autonomy. If cosmic environments shape consciousness, then humanity may not fully control its own destiny. We may be passengers not only on a physical journey through the galaxy, but on a psychological and spiritual journey shaped by forces beyond our awareness. Yet this is not a disempowering idea, it is a transformative one. If cosmic forces shape us, then understanding these forces gives us an opportunity to consciously harness them. We may develop technologies that protect the mind from harmful cosmic influences, or amplify positive ones. We may learn to map the cognitive landscape of the galaxy, identifying regions that stimulate inquiry, creativity, or unity, and regions that foster conflict or collapse. Humanity could one day choose its route through the galaxy based on how different regions affect consciousness. And this leads to an even more profound question. Has this happened before? Could previous civilizations have understood the cognitive geography of the galaxy and chosen their paths accordingly? If ancient species mapped regions that promote cooperation or accelerate technological mastery, then they may have traveled strategic routes through the cosmos. They may have left behind clues, signposts, or structures designed to guide emerging civilizations toward favorable regions. Humanity may be following a cosmic trail laid millions or billions of years ago. Our increasing curiosity, our hunger for understanding, our sense of cosmic destiny may not be accidental. They may be responses to ancient guidance encoded in the very structure of space. If so, then the galaxy is not merely a physical environment. It is a psychological landscape shaped by forces both natural and artificial. And humanity, drifting silently through this vast terrain, is undergoing changes we have barely begun to understand. Every thought we think, every innovation we create, every spiritual question we ask may be part of a larger cosmic process, a process that unfolds not over decades or centuries, but over millions of years, across distances so vast that they defy imagination. In this vision, human consciousness becomes a traveler, evolving as it moves through regions of the galaxy that shape its growth. Our minds, our societies, our dreams, and our fears may all be reflections of cosmic influences. And the journey continues, unseen and unfelt, guiding us toward destinations unknown. If our movement through the galaxy shapes human consciousness, evolution, and perception, then another question emerges, one so immense that it changes not only the way we see the universe, but the way we understand our own future. What if the cosmic environment does not merely influence the past and present, but actively steers the trajectory of civilizations? What if humanity's destiny, our technological leaps, our existential crises, our moments of unity and division, our inventions, our myths, our collapses, our resurgences, are all intertwined with the invisible architecture of the galaxy? If cosmic forces mold the mind, then they mold history. And if they mold history, they may be guiding humanity toward outcomes that we have not chosen, but are nonetheless drawn toward, like a ship pulled by currents across an ocean it does not perceive. The idea that civilizations might follow cosmic patterns is not speculative. It is a logical extension of physics, biology, and sociology. Every species evolves within an environment, and for humanity, the environment includes not only Earth, but the vast cosmic medium through which Earth travels. If different regions of the galaxy alter mutation rates, cognitive structures, creativity, aggression, or cooperation, then human societies, over thousands or millions of years, may be shaped by cycles of cosmic exposure. Periods of flourishing knowledge and innovation might correspond to regions rich in stimulating cosmic activity. Periods of stagnation or collapse might reflect regions that suppress cognition or strain biological resilience. Human civilizations might rise rapidly during phases of intensified cosmic energy, only to falter when the journey carries them into quieter or harsher regions. To explore this idea, we must first understand the timeline of human civilization. The agricultural revolution happened roughly 10,000 years ago, an eye blink in cosmic time. Writing, cities, mathematics, philosophy, metallurgy, astronomy, and religion developed in the last few thousand years. Advanced physics, quantum mechanics, relativity, computer science, and digital technology emerged in the last century. This acceleration is unprecedented. It is as though human civilization has been ignited by a sudden influx of insight, creativity, and ambition. And this timing is suspect because astrophysicists have discovered that our solar system recently entered a region of the galaxy known as the local interstellar cloud, a region with different magnetic properties, particle densities, and energetic characteristics than the space we previously occupied. Could it be that this shift increased exposure to cosmic information or energetic stimuli, accelerating technological development? Humans tend to imagine progress as a linear phenomenon driven by internal factors, ingenuity, curiosity, culture, necessity. But linear progress does not explain the sudden surge of breakthroughs that defined the last centuries. It does not explain why some ancient cultures appeared almost overnight with advanced astronomy, mathematics, and architecture. It does not explain why bursts of innovation occur in clusters across the globe, separated by geography, but united by timing. If cosmic environments stimulate human cognition or open windows of perception, then periods of shared innovation may be synchronized by cosmic exposure rather than cultural contact. If this is true, then humanity might unknowingly be following a cosmic schedule, a developmental timeline defined by the galactic path. Our technological revolutions may coincide with transitions between cosmic regions. Our philosophical awakenings may be triggered by increased sensitivity to cosmic energies. Our sudden insight into quantum mechanics, artificial intelligence, and cosmology may be part of a larger pattern, a pattern encoded not in human culture, but in the structure of the galaxy itself. But what if the pattern is not simply natural? What if ancient civilizations, long vanished or transcended, engineered regions of the galaxy to guide the development of emerging species? If a civilization mastered gravitational engineering, quantum manipulation, and stellar architecture, They could shape corridors of space that amplify or suppress the development of younger civilizations. They could embed regions with specific energetic signatures that stimulate intelligence. They could design areas that act as incubation zones, fostering technological growth. Or they could establish threshold regions, where civilizations face existential tests to determine whether they are ready for higher levels of awareness. Such structures need not be physical in the conventional sense. They could be gravitational configurations, dark matter arrangements, quantum field modifications, or even informational patterns encoded in the cosmic microwave background. If these structures exist, humanity may now be approaching one of them, a region designed to evaluate whether advanced technology leads to wisdom or destruction. The rapid rise of artificial intelligence, genetic engineering, energy manipulation, and planetary-scale technologies suggests that humanity is approaching a developmental threshold. In evolutionary terms, thresholds are dangerous. Species can flourish or perish at such crossroads. Civilizations can ascend or collapse. If cosmic architects exist, they may have designed such thresholds to be navigated consciously, and humanity, without realizing it, may now be entering the most important region of its entire galactic journey. One clue lies in the nature of existential risks faced by modern humanity. For millions of years, life on Earth was threatened mostly by natural events, volcanoes, asteroid impacts, climate shifts. But in the blink of an eye, humanity introduced new risks: nuclear weapons, engineered pandemics, artificial intelligence, climate destabilization. These are not natural, they are technological, and they emerged suddenly, as if human cognition had been accelerated beyond our capacity for self-regulation. This mismatch between technological power and psychological maturity is a hallmark of civilizations approaching a threshold. If humanity cannot develop collective wisdom, global cooperation, or sustainable technology, then passing into regions that amplify cognition could result in rapid self-destruction. But if humanity can overcome these challenges, the same cosmic influences might propel us toward a higher form of civilization, one capable of surviving cosmic timescales and participating in galactic networks. Another clue lies in the nature of human intuition. Throughout history, humanity has sensed that it is moving towards something, some culmination, transformation, revelation, or awakening. Religious prophecies speak of ages ending and new eras beginning. Philosophical movements speak of consciousness evolving to higher levels. Scientific literature speaks of singularities, phase transitions, and paradigm shifts. These intuitions may not be random metaphors. They may be psychological responses to cosmic changes. As the environment shifts, so does the mind. And as the mind shifts, it perceives the coming transition as destiny. If humanity is approaching a region engineered by ancient civilizations, then we may be nearing a point where communication becomes possible, where energetic conditions allow for direct contact, technological integration, or the unlocking of ancient information stored in cosmic structures. Some physicists propose that the galaxy contains regions where information is embedded in background radiation, gravitational harmonics, or dark matter streams. These regions could serve as libraries for civilizations capable of decoding them. Humanity may soon acquire the technologies needed to interpret these signals, not because of internal progress alone, but because cosmic conditions now enhance our cognitive resonance with such information. There is also the possibility that humanity has already encountered signs of such cosmic engineering, but has not recognized them. Unexplained astronomical anomalies, ancient structures aligned with celestial patterns, sudden leaps in human knowledge, and persistent myths about beings descending from the sky may all point toward interactions with civilizations that understood the cosmic environment intimately. These interactions might not have been visits, but exposures, moments when Earth passed through regions containing information or residual technological signatures. If our path through the galaxy influences our trajectory as a civilization, then humanity must reconsider its assumptions about destiny and free will. We have long believed that our future is shaped solely by human effort, ingenuity, and morality. But what if the galaxy itself shapes our future? What if ancient cosmic structures act as guideposts, challenges, or gateways for emerging civilizations? What if our technological revolutions, philosophical transformations, and existential crises are not random, but timed to align with our passage through specific regions of space? This idea does not diminish human agency, it expands it. If we understand that cosmic environments influence destiny, then we can prepare for transitions, harness energies, interpret signals, and make conscious choices about how to navigate our development. We may learn to predict cosmic shifts and anticipate their effects on society. We may create technologies that stabilize consciousness during turbulent phases. We may develop philosophies that frame human existence as part of a cosmic continuum rather than an isolated phenomenon. If ancient civilizations exist, or once existed, they may have mastered such understanding. They may monitor emerging civilizations as they approach critical regions. They may evaluate whether species achieve unity, sustainability, and self-awareness before crossing into dangerous areas. If humanity demonstrates readiness, these civilizations might initiate contact, share knowledge, or integrate us into larger networks. If not, they may allow natural selection to decide our fate. As unsettling as it sounds, this idea mirrors patterns observed in nature. Ecosystems contain transition zones where species face new pressures. Only those that adapt survive. In the cosmic ecosystem, advanced civilizations may occupy regions of stability and knowledge, while emerging civilizations drift through regions of challenge and discovery. Humanity may be entering such a region now, a galactic zone where consciousness expands, technology accelerates, and destiny crystallizes. The invisible forces shaping our journey, cosmic rays, magnetic fields, dark matter, gravitational currents, and possibly engineered structures, are not passive. They sculpt evolution, perception, and civilization. And if humanity can understand these influences, we may gain insight into the deeper purpose of our journey. We may discover that we are not drifting aimlessly through the galaxy, but following a path shared by countless civilizations before us, a path toward a future where consciousness, technology, and cosmic awareness merge. If everything we have explored points to an invisible journey, one that shapes evolution, consciousness, technology, and the rise and fall of civilizations, then the last question becomes inescapable. If we are traveling through the galaxy without realizing it, and if this journey is not a random drift, but a movement through structured regions, engineered corridors, and cosmic thresholds, then what lies ahead? What destination, if any, awaits humanity? And more importantly, have we already been approaching something monumental without the faintest awareness? To begin unraveling these questions, we must first confront an unsettling possibility. The galaxy may not be uniform in its potential for consciousness, technology, or life. Some regions may be barren, others fertile. Some may stimulate cognition, while others suppress it. Some may be safe havens, while others may test species to their limits. If ancient civilizations were truly capable of manipulating cosmic structures, they may have arranged the galaxy into zones, regions designed for growth, challenge, transition, and emergence. The notion of a cosmic transition zone is particularly compelling. Many scientists have noted that Earth appears to be entering regions of space with increasing radiation, fluctuating magnetic fields, and rising energetic activity. At the same time, humanity has abruptly developed technologies that can either elevate civilization or annihilate it. Artificial intelligence, quantum computing, bioengineering, planetary-scale energy manipulation, all have emerged in a tiny fraction of time. This timing is suspiciously synchronized with cosmic changes. If these developments are connected, then the implication is profound. Humanity may be entering a stage of accelerated development because the galactic environment is pushing us toward it. But why now? Why us? Why this moment? One possibility is that the galaxy contains windows of opportunity, regions where cosmic influences temporarily allow for breakthroughs in cognition and technology. Civilizations passing through such windows might experience sudden surges in intelligence, creativity, and innovation. These windows may be short-lived on cosmic timescales, lasting thousands or tens of thousands of years. If humanity is presently inside such a window, then our rapid acceleration is not coincidence, but the natural consequence of entering a zone that enhances awareness. Yet windows of opportunity are not inherently benevolent. They may also expose civilizations to existential risks. Sudden leaps in intelligence paired with insufficient emotional or moral development create instability. This may explain why so many hypothetical advanced civilizations might vanish. The same cosmic influences that elevate them also destabilize them. Species that cannot align their technological growth with wisdom or unity may collapse before they can cross the threshold. If this pattern is real, then humanity is navigating one of the most precarious periods in its existence. But what if these thresholds have a purpose? What if they act like tests? Filters designed to determine whether a civilization is ready for deeper participation in the cosmic community. If ancient civilizations engineered the galaxy, they may have embedded such tests deliberately. A civilization must demonstrate the ability to wield technology without destroying itself, to manage its environment sustainably, and to resolve internal conflict without resorting to annihilation. Only then could it be trusted with knowledge or capabilities that impact more than one world. From this perspective, humanity's current crises, environmental collapse, technological acceleration, global conflict, moral fragmentation, might not be random. They may be symptoms of a civilization approaching a developmental threshold. The challenges are immense because the stakes are immense. The galaxy may require emerging civilizations to prove themselves before granting access to broader domains. But what form would this granting access take? It is possible that when a civilization crosses a threshold, it becomes capable of perceiving or interacting with structures that were invisible before. Much like a child maturing into adulthood, the species might reach levels of cognition or technology that allow it to see deeper layers of reality. Perhaps long-hidden cosmic signals become decipherable. Perhaps ancient artifacts embedded in spacetime activate. Perhaps communication protocols encoded in gravitational waves become interpretable. Or perhaps advanced civilizations, living in higher dimensional structures, reveal themselves only when an emerging species demonstrates readiness. This brings us to an even more tantalizing idea. What if we are already surrounded by evidence, but our minds and our technology are not yet tuned to perceive it? The universe may contain layers of information encoded in quantum fields, background radiation, or dark matter. These layers might require a certain level of cognitive resonance to interpret. If humanity's consciousness is still evolving due to cosmic influences, then our ability to perceive these layers may soon activate. For the first time, we might begin to see the universe as it truly is, not as it appears through the limited filters of our biology. What we call unidentified phenomena, anomalous observations, or cosmic mysteries may be hints of something larger, signals deliberately designed to be recognizable only when humanity reaches the appropriate stage. If so, then our galactic journey is not random or meaningless. It is a path toward awakening, orchestrated either by natural cosmic laws or by ancient intelligence far beyond our understanding. However, this interpretation requires caution. The universe may not care whether we awaken or perish. The galaxy may not be an intentional structure, but an environment with regions of danger and opportunity. Our survival may not depend on passing tests, but on adapting to changing conditions. If Earth is entering a more energetic region, we may face new threats: radiation, cosmic dust clouds, electromagnetic disturbances, or gravitational anomalies. These could destabilize climate systems, biological processes, or technological infrastructure. If humanity does not develop resilience, we could suffer extinction, not by our own actions, but by cosmic forces. Yet humanity's rising intuition suggests something more. The sense that something is coming pervades culture across the globe. From spiritual movements to scientific speculation, from technological futurism to philosophical inquiry, humanity feels as though it is approaching a turning point. This collective intuition may reflect shifts in consciousness caused by cosmic influences. As the energetic environment changes, the mind responds, even before the intellect understands why. If humanity is approaching a threshold, whether engineered or natural, then the next stage of our journey may involve encountering knowledge or phenomena that challenge our deepest assumptions, technologies that rewrite material limits, principles that redefine consciousness, signals from regions we once believed empty, interactions with structures embedded in space-time, and perhaps one day, communication with civilizations that also navigated such thresholds. But what awaits beyond the threshold? If multiple civilizations have passed through similar cosmic transitions, then the galaxy may contain regions where these civilizations converge, zones of exchange, cooperation, or conflict. These regions might act like crossroads, where advanced species meet and share knowledge, or they might be guarded gateways, preventing unstable civilizations from progressing further. Humanity may be heading toward one of these convergence points. Some astronomers point to the galactic center, a region rich in energy, complexity, and gravitational anomalies, as a potential hub of advanced activity. Others suggest the galactic spiral arms act as breeding grounds for life and as pathways along which civilizations migrate. Some theories propose that ancient civilizations have placed monitoring or beacon stations in regions where emerging species are likely to pass. If humanity eventually reaches one of these stations, physically or through detection, it could transform our understanding of reality. But perhaps the greatest revelation is this: the journey may not end. Civilization may continue evolving, branching into multiple forms, expanding its awareness, merging with cosmic systems, and eventually becoming part of the very architecture that shaped its growth. If ancient civilizations built galactic structures, then perhaps they began as species much like ours, long ago. If they endured, they may now exist as consciousness integrated into fields, particles, or dark matter. They may no longer inhabit planets or star systems, but the underlying framework of the galaxy. If so, then humanity's ultimate destiny may be to join this cosmic lineage, becoming both explorers and architects, shaping the galaxy for future species. Yet nothing guarantees success. The threshold before us is steep. The dangers are real, but so are the possibilities. Humanity has demonstrated creativity, resilience, empathy, and the capacity for profound transformation. These qualities may be exactly what is required to navigate the cosmic environment we are entering. If we are traveling through the galaxy without realizing it, then the journey is not a passive drift. It is a process that shapes and tests us. Everything we know, everything we are, everything we may become is intertwined with that journey. The universe may be far more alive, intelligent, and interconnected than we ever imagined. And humanity may be on the verge of recognizing its place within this vast tapestry. Perhaps the greatest discovery will not be that we were never alone, but that we were never still. We have always been moving, physically, mentally, spiritually, towards something extraordinary. And the true revelation may be that the journey itself was the catalyst for consciousness. Humanity is not separate from the galaxy. Humanity is an expression of it, a traveler shaped by the path through the stars, a species waking up to its own cosmic origins, a civilization standing at the edge of a new horizon. If we choose wisely, if we grow wisely, if we understand the nature of the journey we are already on, then the future may reveal wonders beyond imagination. And the galaxy may finally welcome us, not as passengers, but as participants. Thank you for watching. If you enjoyed this video, leave a like and share your thoughts in the comments. Send it to someone who you think would enjoy this topic too. And of course, subscribe and turn on the notification bell so you don't miss the next videos. See you next time.